Are we in 1.8? We're using moment stone and we're using water instead of ice for a boat track. Yeah. Oh, okay, we can use this to teach physics. Like MCC, there's look at MCC to get to the other side, but fast event game. There's a boat track with ice. So we could use a similar version of that, except without ice, and we use water instead. And we uh, we can use this to teach physics. So we can use this to teach distance and displacement. Distance is how far we traveled. So let's say we were at 0, earlier, and now we're at 0, 100, but we have to switch plate, and we're back to 0, 0. So we traveled 100 blocks, but since we ended up back where we started, our displacement would be 0, since displacement is how far you travel from where you started. In our case, we didn't travel at all. We ended up back at 0, 0. Distance, however, is how far you traveled in total. So even though we came back to 0, even though we ended up back at 0, 0 after going 100 blocks, that would still be 100 blocks of distance. And next, we can talk about scalar. Before we explain speed and velocity, we can explain scalar and vectors. So scalar and vectors are different types of quantities. So a scalar quantity only has magnitude. Like distance is a scalar quantity because it only has a magnitude. In our case, it was when we traveled all the way there, 100 blocks. Displacement, however, is a vector quantity. Vector quantities have both a magnitude and a direction. So since we're facing south, we've traveled 100 blocks to the south, but it will be 0 since we didn't end up anywhere. But okay, in physics, we generally consider north and east to be positive values, and south and west to be negative values. So if we actually just ended up at 0, 100 and not back in 0, 0, we would have traveled negative 100 blocks in displacement. Okay, so we can also use this to teach speed, velocity, and acceleration. So speed and velocity. Speed and velocity are different. Speed is distance over time, and velocity is displacement over time. And like we said, distance is how much total area you travel, and displacement is how far you move from the starting position. So in this example, our speed would be 100 blocks divided by the amount of time we took, which I'll put up on the screen because I don't really know at the moment, and then velocity would just be 0 because we ended up back where we started. If we're talking about the moment just before hitting the pressure plate, it would our speed and velocity would be the same. Acceleration and negative acceleration are also a thing. Acceleration is velocity over time. So acceleration, when we're in the boat and just moving, we're moving at constant velocity. So we have 0 acceleration because we're not speeding up or slowing down. And then when the boat is like on the glass right before we hit the water, we're moving with constant velocity, but very little constant velocity, and as soon as it hits the water, it accelerates for a little bit. And then at the end, when the boat crashes and then it breaks, our acceleration is we have a great negative acceleration, and basically drops our velocity to 0, and then we hit the pressure plate and the whole experiment is done. These displacement, distance, velocity, and acceleration all have their own types of graphs, but that's also a big thing, so I'll probably cover that in a different video.